Okay, last question then. Question 1J. Consider a square with side length 2 and center 0, 0, and a circle of radius r and center 0, 0. Okay. Let a of r, some function, be the area of the region that's inside the circle but outside of the square. Fine. And b of r is the region which is inside the square but outside of the circle. Okay, interesting. Which we're following is a sketch of AR plus BR. Cool. Okay, well, so let's maybe visualize what's happening first. This is quite a vague question. If you don't draw a picture, it's hard to see what's going on. So, I mean, at the start, you have some square, right? You have a square like this. Okay. And then what happens is that it seems like in the graphs, the r's go from 0 to 2, right? So when r is 0, then the circle doesn't exist, right? When r is maybe slightly bigger than 0, then it's more like here. Okay. So, then this area outside here, this would be b of r, right? This would be b of r, whereas a of r would be 0 in this case, right? Because no area is inside the circle but outside the square, right? Because the circle is completely enclosed in the square in some way, right? Okay, so as r keeps on increasing, what happens when r equals to 1 is that, well, the circle is completely on the square, it's tangential to the square, right? And when r is 2, then the circle is completely outside already. Right, when r is 2 is already like this. Yeah. Okay, cool. So let's think of these things, all right? And we're going to see which of the graphs are, silly, right? So for graph questions, normally we always use elimination, right? There's no way that we arrive at the correct answer straight away. We eliminate. All right. Okay. So let's have a think. So as I just said, right, when you go from r is 0 to maybe r is, I don't know, 0.5, say, yeah, the circle inside keeps on increasing in area, right? What does that tell you? That tells you that, well, a of r is still 0, right? A of r is still 0 because the circle is still within the square. But then b of r is decreasing, right? The circle gets bigger and bigger, so the b of r is going to be less. Right? I mean, imagine if, in my first picture here, if the circle was bigger like this, then the shaded area will be less, right? So therefore, when r increases at the start, the function should decrease. Right? Therefore, c is wrong because it increases at the start, right? So that's bad. Okay, what next? So what distinguishes, for example, let's separate the remaining 4 graphs into 2 groups, right? So let's say A and D, and then B and E. Okay, so what distinguishes them? All right, the distinction is that some of it, B and E hit 0, but then A and D does not hit 0. Right? Okay, so the question becomes, will A of R plus B of R equal to 0? If a of r plus b of r equals 0, that means that both of them are 0, right? Because they're areas, right? So they're strictly, well, not strictly, but greater or equal to 0. So therefore, both of them will be 0. That means that the circle is bang on overlap with the square. Well, that's pretty impossible, right? Unless you somehow change the shape of these things, which is not allowed. Okay, so b and e are both not allowed. Okay, now what remains is what happens between a and d. What's the difference? I think the main difference is that when r is 2, d is quite high up. Whereas in A, when r is 2, is only, is still quite low, right? So let's check. When r is 2, what is AR plus BR? So when r is 2, B of r is completely 0, right? Because the square is completely enclosed within the circle. Yeah. What is A of r though? A of r is the area of the circle minus the area of the square. So area of the circle is pi r squared, which is pi 2 squared. I hope we could see. Pi 2 squared, let me just check we could see. Yes, we could. So pi 2 squared minus what? Minus the area of the square, which is 4. Yeah, 2 times 2, which is 4. Okay, so pi 2 squared is around, well, pi is 3.14, right? I'm not an engineer, so I'm not going to say 3, but okay, 3 and something. So if it's 3 and something times 2 squared is like 12 and something, right? Okay, so if it's 12 and something, then 12 and something minus 4 is 8 and something. Right? Okay, so when r is 2, the function AR plus BR is 8 and something, which corresponds to D. Yeah, A is a bit too low. A doesn't rise quick enough. So the correct graph is D.